Hey guys, Mr. Middleton here. Today we're going to talk about proving triangles congruent by using side, 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 and side angle side. At the end of this video, you should be able to identify side, 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 and side angle side congruence between two triangles, and you should begin to prove two triangles are congruent formally, like in a proof. Okay. Reminder from last lesson that how many parts have to be congruent in a triangle before we can say that triangles are congruent? 6. We need to be able to say that all three angles and all three pairs of sides are congruent to each other. So we have 6 parts. We have 5 shortcuts that allow us to prove the triangles are congruent. Each shortcut requires 3 parts to be congruent instead of 6. However, the order does matter. Okay, so these shortcuts essentially cut our work in half. Instead of having to show that 6 things are congruent, which we really can't do all 6 unless we have a lot of information given to us, we'll find a way to cut that down a little bit. Okay, and the first shortcut is the side, side, side postulate, or SSS, side, side, side. Okay, I won't say SSS. Okay, but if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. That is the side, side, side postulate. It basically says, hey, if all 3 sides are congruent, then we know that everything's going to be congruent. So we don't need to prove the angles. If I show you that all 3 sides are congruent, I don't need to show you that all 3 angles are congruent. The side angle side postulate says if 2 sides and the included angle, and we'll talk about what that means in a second, of one of the triangles are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. Straighten that out a little bit. Alright, so here, let's talk about what included means. Included angle means it's going to be in between the 2 sides that we mark. Okay, it's going to be in between, locked in. So, let's name the included angle in these. For this triangle, we have HY and HD. They're marked. So our included angle is going to be the angle between those 2 sides. Okay, or made up of those 2 sides. So which angle is made up by HY and DH? Well, it's this angle, angle H. So angle H is the included angle. In B, we aren't really given 2 sides to begin with, but we can work with that. In B, we have 2 triangles. If you look at them, we have triangle FKL, we have triangle FGK. FKL, KFG, probably. But we have these 2 triangles. We have these parallel signs. And remember I told you that anytime you see parallel lines, your first thought needs to go to corresponding angles. Same side interior angles, alternate interior angles. Okay, so make sure you're still on that track. But to start off with, I see FK. FK is in both triangles. It's in this one and this one. It's a shared side. And so I know that FK is congruent to itself. So I'm going to mark it. Even though it's one side, I'm going to mark it because seeing the markings helps me to identify my shortcut a little bit faster, and it'll help you as well. Okay, and now I need to find out what my included angle would be. Remember, my included angle happens in between the 2 sides I have marked. So I have FK and FG marked. What angle is made up of those 2 sides? Here, GFK. Here I have LK and FK marked. What angle is made up of those 2 sides? Angle LKF. So I'll say angle LKF and angle GFK. Alright, and so those are my included angles. Flipping to the back, let's use some of this. Alright. Can we conclude that the triangles are congruent? If so, give the congruent statement and justify. If not, tell what other information you need to prove that they're congruent. So we just have 2 shortcuts that we talked about, side, 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 side angle, side. That's what we'll focus on in this video. And so we're given these 2 triangles with the markings. They're not asking us to write a proof or anything yet. But we know we should be looking for one of those shortcuts. So first things first, is it side, side, side? No. They gave us 2 sides, but not the third. Okay. Is it side angle side? Because they gave us two sides and an angle. Is it side angle side though? No, because for side angle side we need to have an included angle, not just any angle. So in both of these we have W and R, but you'll see that, or you should see, that they are not the angle that's made up of our two marked sides. Our included angles would be V and T. See how those are made up of the sides? So can we say that these are congruent? The answer is no. What other information will we need? We need to know that angle T is congruent to angle V. If we knew that, then we could say, oh yeah, these are congruent by side angle side. But we don't. Okay, next example, we have these two triangles. I'll say MLK and KJM. And we need to know if these are congruent. So just starting off, they only gave us two things. They gave us two sides. But hopefully you guys see by now, because I think we've talked about it a couple times, we have a shared side, MK. MK is shared. Okay, and so that means it's part of both triangles. And it has to be equal to itself by the reflexive property. So can I say that these two are congruent? Yes, I can now, because I have side, side, side. Side, side, side. And so now they're asking me for a congruence statement. Remember, that means what's congruent. Say what's congruent. We'll say triangle. And my trick is always to follow the same pattern of marks. I'm going to go from one mark to two marks. So ML, make up the one mark. LK makes up the two marks. So MLK is congruent to triangle. Okay, so I went from one mark to two marks. So one mark to two marks. KJ and JM. So MLK, triangle MLK is congruent to triangle KJM. And the justification is just the reason. So it's like the second part of your proof. Why can you say that these two are congruent? Well, because of the side, side, side. SSS. Alright, so a couple quick examples. Let's go into a full-blown proof. Okay, they want us to prove that triangle ACD is congruent to triangle ECB, and they don't tell you how to prove it, they just say prove it. And so our given, what we'll start with in this situation, is that C is the midpoint of DB. Okay, and I use some abbreviations. Okay, C is the midpoint of DB. My reason for saying that is it was given to me, given information. Okay, now, anytime I have a proof or a statement, I want that statement to lead to a mark. It's either a mark that's already there or a mark that I get to write. C is the midpoint of DB does not let me write a mark. Okay, so I need to think, okay, how am I going to use this to get to a mark? Either saying that angles are congruent or sides are congruent. If C is the midpoint of DB, what do I know? Well, I know that C is in the middle of this thing. That means that this, DC, should equal CB. Or should be congruent to, CB. Okay, and why do I know that? Well, that's what a midpoint is. Remember that anytime that's what we say, it's definition of whatever we're talking about. In this case, it's definition of midpoint. Okay, so I made my marking, so I feel pretty good about that. I can move on. Okay, my next thing, they gave me something else. It wasn't in the statement, but it was in the diagram. They told me that AC was congruent to CE. And that was given. Okay, and again, that was already marked for us, so I feel pretty good about that being one of the statements. All right, what else can I prove? Well, I have two sides, so I'm either going to have to prove a side's congruent or I can try to prove an included angle. Now, I don't want you thinking like, oh, let me just say one of the two, because that won't get you, I mean, that's only giving you a 50% chance. But here, I see an X. Anytime I see X, I'm like, oh, vertical angles. And so I do have vertical angles here. I know that this angle, ACD, should be the same as this angle, ECB. So angle ACD is congruent to angle ECB. Remember, I can't just say angle C is congruent to angle C because I don't know what angle I'm talking about. I could be talking about 4 different angles here, right? So I need to be really specific with that. And I know they're congruent because of the vertical angles theorem. Okay, that says that all vertical angles are congruent to each other. And so now I can say, hey, I got side angle side. So I'm at my proof. I can say triangle ACD is congruent to triangle ECB. And why can I say that? Side angle side. All right, and so that's the proof. We'll get into more of those as after the chapter gets to winding down. You guys will be masters at proofs. But at the end of this lesson, you should be able to use side, side, side. You should be able to use side angle side. You should be able to find out what information you need to prove a proof is congruent. And you should be introduced at least into proving triangles congruent formally. Okay? See ya.